Good morning, everyone. My name's Kurt. I'm from Microsoft, and it's my pleasure to introduce Paul Glavich from Readify and Chris Paget from Kloud today. Kloud and Readify are platinum sponsors at Ignite this year, and you're going to have the pleasure of listening to some exciting content, and invite you to go visit them at the expo during the day if you want to find out more. So yeah, without much further ado, over to Paul and Chris. Thank you.
Okay, thanks everybody for turning out for the 8:15 session, sponsor session at that. So thanks again. There's more than one person, so I'm pleasantly surprised. I'm Paul Glavich from Readify. I'm a principal consultant with Readify. I've also been around the traps for a few years. I've spoken at Tech Ed and written a few books and things like that. And Chris?
Chris Paget from Kloud in Melbourne. I'm an app developer. I can double down as an infrastructure programmer. And I like to do that because it makes apps easier to deploy, faster to deploy, more reliable to deploy, more repeatable to deploy, more secure to deploy. So that's what Glove and I will be talking about today, is maybe not where dev meets ops, but where devs meet ops. So anyway, cool.
All right, just as I guess a bit of a backstory, as I mentioned, as been mentioned, Chris is from Kloud, and Telstra has actually purchased Kloud. I'm from Readify.
We like acquired.
And Telstra's actually purchased Readify. If you stay for the duration of this presentation, there's probably a good chance you'll be purchased by Telstra as well. So.
That's the door prize.
That's right. Okay, so the agenda for today. There's been a few DevOps talks thus far, so you're probably well aware of what DevOps is. We will talk about it, what it is in brief, but mostly around what we think it is and what it means to us. We'll talk about the components that are involved in DevOps, as well as sort of breaking them down in a bit more detail, show you some of the steps within a CI pipeline, CD pipeline, monitoring and feedback, those kinds of things. And we'll predominantly be using VSTS for that, but we're not strictly limited to that. And towards the end, we'll kind of show you a full stack in terms of the whole CI/CD pipeline. But at the end of this, we'll show you how to sort of get up to speed or actually build a CI/CD pipeline in probably about 10 minutes. So hopefully by the time you get out of this talk, you'll be able to do exactly the same full CI/CD pipeline in around 10 minutes. There are a few slides, so we've attempted to throw some jokes in between. All the good ones are mine, and all the bad ones are Chris's. Yeah. Okay, click, click, click. All right, so DevOps. It is a pretty popular buzzword at the moment, but from my perspective, it's kind of what, as for me being mostly a software guy, is what we should have been doing in the first place. It's not just building a bit of software, making sure it sort of runs on your machine or in a particular environment, and then letting other people deal with it. For me, it's about building some quality software and making sure that that can get from concept all the way through a build pipeline, through various quality gates, making sure you're working with operations teams, security, and get to release, but not only in release, continue to work well in production, making sure it's monitored, making sure you get some feedback and improvement around this big cycle. What the canonical definition is, people, process, and tools, and while that's certainly true, it's just about making sure that you're seeing the end game. That's really, for me, what DevOps is about. So you're looking at it to get to production, making sure it is running well, and making sure you're continually improving and iterating upon that. Chris?
Yeah, just to add to that, I think you have to have a cultural acceptance of focusing on DevOps across stakeholders. So it may not be the developer team, it's the operations team, it's the business stakeholders and others who are involved in delivering IT solutions, and trying to focus on delivering those IT solutions more reliably, more quickly, more cost effectively. I don't personally believe that there is a one-size-fits-all DevOps. I believe that by adopting DevOps, you want to fit it to your particular organisational goals and your processes and maybe some of your existing tools. So it's when I talk to customers about DevOps, it's really about helping them get started with a DevOps plan that fits their particular organisation and the people involved in that. So it's not all just about the tool chain.
First joke.
That's one of yours, Paul.
All right, a bit of laughter, that's okay. It's better than groans at least.
That's polite laughter from Kurt, I think.
Okay, so component overview. This is what we're going to be talking about mostly today. We're going to start off with some tooling, and we're not going to advocate any specific tooling. Being a Microsoft conference, we'll probably lean towards that side, but you know, we're pretty agnostic, and so is Microsoft lately as well. We'll talk a little bit about the environment, what that means from a CI/CD perspective or DevOps, and what are some of the considerations you should factor in. Obviously, continuous integration and continuous deployment. I'm going to break down some of those areas, show you some of the steps involved in those, some of the steps you should consider to take, and how you might start to approach to build those out. And finally, the monitoring and feedback of that product once it's in production, and how you might also accomplish those things and push that back into a cycle so you get this iterative loop going on. Chris, I'll leave you with this one.
Take this one. So I think when you begin to consider DevOps and plan for it, in my mind, there's three key things you have to consider, or questions you have to answer. First one is, what are you deploying to? This can encompass a number of things, but at a basic level, it kind of, for me, fits into some key areas, like, are you planning to deploy applications to an environment that you want to support blue-green deployments, perhaps canary deployments, excuse me, rolling deployments, maybe into multi-region deployments, multi-tenant deployments, so on and so forth. So you have to understand your deployment target before you can start to build your DevOps pipeline up. Once you've decided that, you can then ask yourself what you're going to be deploying on. Of course, with Azure and other clouds, you have a number of services that you can deploy on, whether it be kind of Azure App Service Space, for example, or Azure Cloud Services, maybe infrastructure services running in public cloud. It may be deploying to container services in a public cloud. Regardless of that, I think what you want to achieve with DevOps ideally is deploying to immutable infrastructure, which I'll describe in a little more detail in a moment. So you've kind of answered, what you're deploying to, what your deployment target is, what your deployment infrastructure is likely to be, and then what you want to then ask yourself is what you're deploying for. What's your desired configuration of that infrastructure for those targets? That can be a desired configuration that will ensure compliance with that infrastructure for those targets, maybe your reliability requirements, your security requirements, so on and so forth. So three key questions to ask yourself before you start to break your environment up to determine what you'll be deploying to. Dev experience?
Yeah, and finally the dev experience. There's not a lot that's actually been talked about from a CI/CD perspective for the dev experience, but it is really important. Quite often people set up a CI/CD pipeline and get it all, say, pumping up to Azure, have this fantastic pipeline, but the dev experience itself can be a little bit different, particularly with the environments. And I'll give you an example. Say you're, who's currently using, say, app services in Azure at the moment? Okay, so a reasonable amount. So say you've got a CI and CD pipeline that's deploying to an app service. There's a cool feature in Azure called App Service Authentication. And so you turn that on for your app service, and it can use sort of OpenID authentication across for Google, Active Directory, Facebook, whatever. And you turn it on, there's a few clicks, you enter some details, and bang, things are authenticated for your app service. And that gives you a fully qualified security principle when it gets down to your application. However, from the development perspective, if you're working on your local box, you don't have these bells and whistles that you can simply turn on. So you have to kind of do a little bit of extra work if that's what you're doing in Azure to simulate that on your local dev environment. Otherwise, you're not going to be programming against or developing against the same experience. You have to make sure you can kind of simulate both. So make sure that these things are taken into consideration, that your dev experience will also mimic what your CI/CD pipeline will eventually deploy to.
So I've already mentioned immutable infrastructure. Maybe just to go back a couple of steps before we explore this a little further. So traditionally, as IT pros, we've built virtual machines up, or physical or virtual machines up, and we remote desktop into them, and we configure stuff, and we install stuff, and we patch it, and we update it, we upgrade it, and so on and so forth. That's really known as artisanal infrastructure that's crafted by hand, like clay makers do, and so on and so forth. So that's kept us busy for a few years, for many years. But what it does introduce is kind of the notion of drift, of configuration drift. So if you have to apply configuration, patch it and update it for a single virtual machine and repeat that multiple times, then over time that will introduce drift into that desired configuration. Okay? The idea of immutable infrastructure is you build a virtual machine up once and you don't patch it thereafter. It does not change. It becomes immutable. There's other terminology that's used with regards to immutable infrastructure. The artisanal approach produces snowflake servers that are unique for the most part and are not repeated. Okay? By producing immutable infrastructure, you're building what are known as Phoenix servers that can be set up, torn down, set up, torn out, set up, torn down. They come and go with time. So the general idea behind immutable infrastructure is it eliminates the configuration drift of infrastructure. And really, as I mentioned earlier, what it boils down to is every time you want to deploy a new release of a given application, you build the infrastructure up to host that application, to deploy that application to, and then you effectively lock it. Okay? For the next release of an application, you build the infrastructure up again. You may change the configuration for that particular release from the last one in order to meet a new feature or support a new function, and then you lock it, and so on and so forth. Okay? What this can also allow you to do is over time, once this is fully automated and become a kind of a reliable, repeatable process for you, is you can, on deployment of a new release of a given application, you build your immutable infrastructure up for your development environment. Okay? And then rather than have to build it up for your test environment and your staging environment, production environment and so on, you can just promote your immutable infrastructure through environments. So you build it up for development. Once the developers are ready to release it to test, or the testers are ready to pull it into test, you can move that infrastructure as is into your test environment by a DNS change, for example. You can then promote it from test to staging, staging to production. With the next release of a given application, you build the development infrastructure up again and then promote that through environments. So it's quite a new way of thinking about how you manage infrastructure through environments and deploy apps to that infrastructure. Does that kind of make sense to people? Yep. Key thing is you build it up once and you never configure it, patch it, or update it again. Cool.
Next joke. Little snigger. All right, that was Chris's.
That's the only one I got, actually.
Yeah. Okay, so a little bit about the tooling. Again, it would be remiss of me at a Microsoft conference to not talk about Visual Studio Team Services. It is a very comprehensive tool set, though, from a CI/CD perspective. And in the market, it's, as far as I know, it's the only tool that covers everything in the CI/CD pipeline in the DevOps space. There's a whole lot of other tools listed there as well, and they're more targeted at certain areas, but VSTS certainly is one of the most comprehensive out there. It's one that I'm most familiar with. I have used Octopus and a few others as well. Octopus is a favourite of mine as well. It's very good at release management. And these other tools don't preclude the use of VSTS. They can all work together as well. Jenkins, Puppet, Chef, they're all excellent tools and they can work together with VSTS. So I'm not really advocating one particular one, but it is important to know what your organisational preferences are, what your skill sets are targeting, and this will determine what the tool set used is. It is also, I guess, from a tool set perspective, it is important and it's not important. The most important part really is I guess, investing in the process to get it all done together and not simply act in these siloed compartments within your organisation. So once you've got that agreement to say, hey, yeah, we're all in this together, we're all just going to work towards getting a good release product, then this tool set becomes a secondary consideration. Again, important, but not the be-all and end-all of things. Is there anything you want to add to that, Chris?
Yeah, just in relation to the last slide, immutable infrastructure. Many of these tools can contribute to you deploying to immutable infrastructure. And by doing so, not only by automating through these tool chains, for example, and deploying to immutable infrastructure, collectively that allows you, like we were alluding to a little earlier, the ability to deploy apps easier and faster and more reliably is really the result of bringing all these tools and concepts together. One of the things I do want to call out here, especially about Jenkins, for example, is that, as I mentioned earlier, I'm an application developer. Right? I write application code as my day job. But I also enjoy infrastructure programming, i.e. Coding infrastructure or managing infrastructure as code, but also managing pipelines as code, right? So for me, unless you can code it, it's going to be a bit laborious. So if I can code applications and I can code infrastructure and I can code the pipelines, such as a Jenkins pipeline that manages that infrastructure for me and deploys my applications to it, that's brilliant. I'm lazy at the end of the day. I'd rather spend my time investing in coding all that so I don't have to repeat it the next time. So Jenkins is a good example of that. Jenkins is a kind of general purpose automation server that you can automate builds, tests, deployments, so on and so forth. And you can codify that using a Jenkins file as a good example, right? You can then check that pipeline code, that Jenkins file, into your source control alongside your infrastructure code and your application code and manage it all as a kind of a single unit of work. It's quite a powerful idea.
Yeah, it's worth noting that at no point of time, with all this automation in place, you're going to have to do some scripting. And more often than not, you'll have to do some PowerShell, but it may not be PowerShell. But the scripting component of it is pretty much ubiquitous across all the tool sets. It'd be very rare that you just get a few button clicks and everything is set up for you. So be prepared to do some scripting. And again, just make sure you're comfortable with the scripting tool of choice and that it works for your team and organisation.
So to make the immutable infrastructure idea a little more real, perhaps, with support from the tools that we mentioned on the previous page, I guess this deployment diagram features a few icons, but I'll just talk to it generically before focusing on tools. So I'll maybe work from the right to the left. So you're deploying a new application or a new version of one. With immutable infrastructure, as I mentioned before, you're not deploying it to your existing infrastructure, okay? If you're using Azure App Services or Cloud Services, you might be aware of deployment slots. They, in effect, provide a way of you not mutating your existing infrastructure, right? So in those particular cases, you'll be deploying, or you can deploy to a staging deployment slot. In effect, that's building the new infrastructure up to deploy your new version to, and then you swap that into production once it's ready and tested and so on, and verified. If you're using containers, then you can build containers up, host them, test them, warm them up, verify them before you swap them into production. If you're using Azure Infrastructure Services virtual machines, you build them up, and then once they're tested and warm and verified, you swap them into production and effectively swap the old infrastructure out and tear it down, okay? And you repeat and rinse for each version of a given application. In order to support that, there's a number of tools you can use. If, for example, really the first step is to, if we take it from an infrastructure services point of view, you're building virtual machines up, the first thing is to build the virtual machine up from a base image. And then as a second step at the bottom here is then to configure it up. Maybe that is to install a Windows feature on a Windows server, for example. It may be to install some a third-party agent or drivers or libraries, whatever else it may be. So having built the virtual machine up from a base image, you can then configure it, apply your desired configuration to it. And in the case of using tools such as PowerShell DSC, desired state configuration, you can not only apply that desired state configuration, but ensure that those virtual machines remain in compliance with it. I'll come back to this in a moment. So having built the virtual machine up, applied this desired state configuration to it, enabled features and roles and so on, you then deploy your application to it, and at that point it becomes locked. You attach it to a load balancer, so users can start using that new version of the application. Does that make sense? Yep. So as I mentioned, Azure provides, different Azure platform services, infrastructure services provide different ways of achieving this, but that's the overall concept. Right? Of course, what it also supports, if this happens to be a bad build or a bad release, you can always, before turning this off and tearing it down, you can always revert to the previous version. Just back to this. So I mentioned PowerShell DSC allows you to effectively define what your desired configuration is of your virtual machines running your new application or running applications. And not only allows you to apply that desired configuration, but keep it so. So it makes it so by applying it and keeps it so by keeping it in compliance with the desired configuration. A useful tool to look at, in order to support that, you must, or you can host what's known as a pool server. So when these virtual machines are started up and installed with a configuration management agent, they pull the desired configuration from your pool server and then apply that desired configuration to those virtual machines. Azure Automation hosts a pool server for you. So with a few clicks of a mouse button, you'll have a desired state configuration pool server hosted for you by Azure Automation. When these virtual machines are started up, they will then attach to that pool server and pull the desired state configuration for you. It's mentioned here that NuGet can be used as an application deployment mechanism. That's a bit rare. Octopus uses NuGet to deploy applications. So often we use NuGet to manage dependencies and frameworks and libraries that we want to depend on for applications. Octopus server uses the NuGet feed to manage versions of applications because NuGet's the package is quite a useful way of describing assemblies and the metadata related to those. So does that kind of all make sense? Key thing here is that ideally you have a single build that you can release into multiple environments. In each of those environments you want to build new infrastructure up, apply configuration, deploy apps, make them live to users, and ideally even promote this new infrastructure through your environments as you move from from dev through to test to production. Cool.
Another joke?
Yeah, I did not get this one until I read it 3 times.
All right, we'll move on from there. Yeah. They don't get any better. Okay, so CI, continuous integration, just starting off on this. First off, branching strategy. Everybody's got one, or at least should have one. It's something you need to consider as part of your CI pipeline. You can have a CI pipeline that's just, say, going from a master branch, but if you're, say, doing feature branches, and they might be long-running feature branches, they shouldn't be, but, stuff happens. So you're developing a feature branch, it's going on for some time, you want to make sure that the quality is maintained as that development occurs. So you might want to consider having CI pipelines for a particular feature branch or multiple feature branches. And given that you can script out a lot of the CI/CD pipeline, as we'll see later on, this isn't so arduous as it may seem. There is a cool feature that I only recently found out about in VSTS though. So in your CI pipeline you can have builds triggered for any branch. But now in your CD pipeline, your continuous deployment, you can actually filter what branches are actually deployed along the pipeline. So you can have your CI pipeline building every branch, but your CD pipeline only deploying from, say, your mainline or your release branch. And Visual Studio makes that quite easy. Actually, I might just jump into that quickly just to show you. Okay, so I've got my DevOps Deep Dive demo Team Services account here. Can you guys see that okay? Everybody at the back? Yep, seeing nods? All right, cool. Okay, so let's just go and edit this. Okay, so I've got a CI pipeline here. We're doing things like running Bower and some .NET Core restorations, running tests, etc. Before I get into the details of that, if I look in the triggers here, you can see I've got continuous integration checked and the branch filters, in this case, ref heads master. And I can add new branches to check there. But in conjunction with that, if I go over to releases, and I'll go into a bit more detail about the CI and CD pipeline very soon. Come on. All right. And again, here in triggers, continuous deployment, and I can trigger an artifact source. This is my CI pipeline, and again, I can select a branch to deploy from. So it makes it quite easy. If you are using multiple branches, you want to ensure all the branches have a consistent quality, so you can trigger builds on all specific branches, but only deploy from authorized branches, I guess you could call them. So moving down the chain, unit tests, we should all do them. I assume you know what they are. They're best, particularly in new projects, start adding them from the beginning and adding them into your CI pipeline. They are typically tests that run very quick. They don't hit a database. So the idea here is that you fail fast. So if you've done a check-in, it does a build. If the build passes, it runs those tests. The unit test typically should be run first, and that way if there's any immediate failures, that'll fail the build, and you'll get immediate feedback and you've got to go and fix them. With legacy code, if you've got an existing project and you think, right, I want to start doing CI/CD against this old project, depending on how that is, say, architected and constructed, it may be a little difficult, particularly if there's highly coupled code. So in that instance, unit tests may not be immediately applicable, and you might want to defer to something like integration test, which I'll talk about very soon.
Do you want to mention code coverage?
Yes, and code coverage. Code coverage is a good metric to say how much of your code is being covered by the tests. It's tempting to try and get 100% code coverage, but I wouldn't really aim for that. It's a bit of a fallacy in that 100% code coverage guarantees extremely high quality. Probably just means you're running tests across your code, sure, but you're just not providing enough inputs to demonstrate the failures. So 100% code coverage may feel good, but it's probably not worth the effort to get to 100%. If you're doing, say, 70 or 80, that's probably quite fine. I mean, if you want to get to 100%, sure, go for it. But you will feel a false sense of security to say, hey, look, there's no bugs in this code, and that's not quite right. And again, the effort to try and get there is usually, to get to 70, 80% is good. To get that extra 20% can take you, maybe 60% of the time. So the value really isn't there. You can see up here as well, which is similar to the one I just showed you, VSCS. I'm running some tests here at the moment. In this case, there's only one test run because it's only quite a small project. But again, typically you do unit tests, then integration tests, which I'll talk about next. So integration tests are usually cover a lot more code than unit, which are again very isolated bits of testing. The integration test may span a lot more classes, a lot more layers in your application. They're often viewed as adding a bit more value because if you do one integration test, they'll typically cover a lot more surface area than one unit test. So the tendency is to do more integration tests because you do less work to add the test, but they do cover a lot more code. However, they can run quite slow as you've got to set up data. Maybe they are hitting the database. You've got to construct up some data in your database so that you've got a known set of inputs that when you run a test, you know what the configuration is and you can assert the right conditions. If you've got weird, wacky data in your database, you're not sure what's happening when you're doing a particular test, you can't really assert properly the result of the test. So these tests are valuable, but they can take some time to run. That's why we run them second. So that unit tests run quick, bang, they're passed. Hit your integration test, which may take quite a bit longer. So that's why we run it as the next step. So you want the quick feedback, and this is kind of working down the chain. For legacy old code, again, which can often be tightly coupled, hard to split apart, you typically don't want to have to refactor everything just to start adding tests, so you want to sort of do that as you go along. With legacy code, you can if you've got this big ball of mud, you can kind of start from the top and start testing at the very top of your application and potentially also coming in from the bottom end in that maybe you're hitting the database first, but over time you can start to refactor and abstract that database layer so that you can actually mock that out and still doing integration tests, but slowly attack it from the top and the bottom and slowly start to refactor your code so it makes it much more testable. But again, from a legacy perspective, you kind of don't want to have to spend 6 months tearing everything apart just to get your CI pipeline running some integration tests. At least add some tests, even if they're not optimal, and begin by building that out. Again, it's not, we're not talking about the big bang approach here, and that's the same with everything when you start out your CI and CD pipeline. You don't want to just build it out immediately, although you can at the end of this talk. I'm hoping you'll be able to. But you do want to start somewhere, so don't try and be deterred by how much work it seems that it's going to take to get past. Static code analysis. So we've got some tests running, like unit tests, that's all good. We've got integration tests, they pass. So we're feeling pretty good about ourselves. But again, you may not have enough code coverage, you may not be testing all the things you want, and there's probably aspects in there that you're really unaware of. There's some static code analysis tools that you can use. So after the tests have run, you can run these static code analysis tools against your code to provide further insight. And there's some good stuff, even in Visual Studio, you've got like FX-cop kind of rules that you can apply, and it'll pick up some bad coding habits. There's tools like SonarQube and Endepends, which will provide some really good detailed analysis over your code. In fact, I'll show you that right now. So I'll go back to a build definition. I'm glad the internet's working at the moment. I come in this morning and my machine started to do a Windows update and come back and it was close. Sorry, that's not that one. Builds. Okay, so here's my CI pipeline. I'm doing a .NET Restore, so .NET Core app. Running some tests. I'm converting some code coverage results just so it's easily consumable. And after that, I'm running a SonarQube analysis. And again, SonarQube is a separate product outside of VSTS. It's something you have to set up separately. But you can pass your code over to this system, and I'll show you the results of that in a second. So we can provide further analysis. In VSTS Marketplace, there are free add-ins that will allow you to run a SonarQube analysis. You have to provide the server to do it, and it's similar for other tool sets as well. But VSTS does provide some really good Marketplace add-ins to allow the running of that quite easily. And so it's a pretty simple set of arguments there. I've defined my SonarQube server, and all that definition has is an endpoint at where it exists. And I've got project key and project name there. And I've got my SonarQube endpoint here. Let me just refresh that, make sure it's all good. And so you can see it's saying I've got no bugs, but I do have some vulnerabilities. If I click on that, and I've got, let me just try and zoom that in a bit. Okay, and this kind of site.js, of course, it's JavaScript code. Where else would the bugs be? I've got this B rating. If I go into there, and you can see that I've actually got some console logs in there, so it's highlighted the fact that that could be a security risk for me, which is kind of cool. I haven't really had to, you can use JSLint and all these kinds of things to ensure JavaScript code cleanliness, but SonarQube does a hell of a lot more for you as well. And it'll try and identify where you've got possible null reference exceptions and things like that, and give you a pass or fail rating. And at the moment, I'm doing okay. You know, I've got my quality gate has passed. But you can go and download SonarQube, and again, there's other tools out there. In this case, I've downloaded it. I created a VM in Azure. I've set it up, opened up an endpoint. Now I'm just pointing my CI build at it, and you can point other CI builds at it as well.
Just one other thing I want to point out here is other than your 23 code smells.
Damn, they could see that.
Is that metric that's reported next to it, debt. So both Endepends, which is another one of the tools we mentioned, and SonarQube kind of calculate your technical debt as you're developing code. So effectively it allows you, or will answer the question, have I just developed code that's included debt that I'll have to repay later with 30 minutes of effort or 2 hours of effort in this particular case. So 2 hours may not worry you, but if that's 12 hours tomorrow and 24 days the next week, you know you're kind of building debt into your application as you're developing it out. It's got a good metric to keep an eye on.
Yeah, absolutely. And I guess how you choose to act on this within your team, this could be just something that you email around or you show your team, you put on a dashboard, whatever. That kind of action is up to yourself. The fact that this information is there is great, and just decide on the best way to act on that.
So one of the
Yep, so you have to, no, at the moment there's no service to set up. Same with Independence, you've got to spin up a VM, so there's a bit more effort involved. But it's relatively easy. You get an MSI, you install it, click a few buttons and you're away and the VM's going. So there's a bit of extra cost to that. But it is reusable across other CI pipelines, so it doesn't have to be one project per SonarQube instance. You can have heaps of them.
Yep, so Independence and SonarQube are code quality management tools. There are also some code security analysis tools. A good example of one of those is HP Enterprise's Readify. That's an acquisition they made a little while ago. So it will scan your source code for any potential security vulnerabilities about, for example, how you're managing cookies and the properties of those cookies and so on and so forth. Items in your web config that you may have to consider that may introduce some vulnerabilities as you move towards production. So again, there's plugins from the Visual Studio Marketplace to allow you to get started with that particular tool as well. That's a good one.
Come on. Hard audience.
We should be following Twitter to see how much of these are really actually.
All right.
Your CD pipelines have jokes in them, don't you? Just
Yeah.
in the build logs.
I thought, wow, they're going to be asleep now. I'll put some jokes in. Yeah. Okay, so onto the continuous deployment pipeline. Chris was talking briefly about configuration. And typically in your CD pipeline, particularly as you're migrating through environments, whether you be spinning them up, tearing them down, or you're just doing a process of promotion, and we'll have a look a bit more about that soon. You want to change your configuration based on the environment so that it works for the environment. And simple things like database connection strings are going to be pointing at different database servers per environment, whatever the case may be. You want to make sure that configuration is applied per environment. And all of the tools that were mentioned previously, they all have various ways of doing that. VSTS does provide a token replacement service. It's only recently started to do it actually, and I'll show you that in a second. Previously with VSTS, you'd have to go to the marketplace, and there's a tokenizer marketplace add-in, which you can just add in for free. And you'll be able to put these little tokens in your configuration, and you specify variable values. Again, I'll show you that in 1 second, and they just get replaced as part of the CI and CD pipelines. But recently, they've added built-in support for variable replacement. But that's kind of, I guess, simplistic, because you don't want to put secrets into your source code. You want to make sure that kind of no one really has access to it, only the necessary people, but they are still applied per environment. You don't want to have to share them with everybody. So if you've got some really complex secrets to manage and replacing your config, you can use some config management database, which is the CMDB. And Azure has this Key Vault functionality, which has some really high security kind of concepts. It has hardware storage modules that will encrypt your secrets and perform, I guess, a huge degree of security across those. And you'll be able to use things like PowerShell and all that to extract those and use those in your configuration for each environment. It's a little bit more work to do, but it's a value trade-off, right? If you're, depending on how sensitive your secrets are, will determine what kind of a configuration store. And that's only a few that I've mentioned as well. And I'll just show you, I'll just jump into Azure, the CD pipeline that I've got, for how you might define that. So back to my release definition. Okay, so I've got 3 environments here, dev, QA, and prod. And at the top here, I've got variables, which are kind of like a global variables that'll be applied to everything, but I'm not too concerned with that at the moment. If I go here into dev, right-click here, and say configure variables, I've got some variables here which are specific to my development environment. And all they are at this point of time is defined. Okay, so I've got my secret variable, environment description, and a few other bits and pieces there. So by themselves, they're just defined. I'm not really doing any replacement here. But what I can do, and I mentioned that this has recently been added to VSTS. So you see this little version 3 over here. Can everybody see that okay? Yep. And that gives me this file transform and variable substitution options. And at the moment, I'm just doing a transform of the app settings.json. Previously, this wasn't available. Again, it used to be just on the version 2, and you can see that that's actually gone. But now that we've got that, I'll just have to refresh that, we can do it within VSTS. So again, I've got my variables. I've got it defined to say, okay, have a look in app settings.json when you're doing this dev deployment and do a replacement. I'll just show you quickly where that is. Let's say for, going back to the variables, I'm looking at environment description, Kloud dev. And I've got this pretty simple application, and I've got my app settings JSON file, and I've got environment description. In this case, it's local development. But when it gets to dev, it's going to replace it with that value Kloud dev. And just as sort of proof of that, if I go into the Azure portal, I've got a few resource groups here. In this case, the DevOps Deep Dive Demo Dev, representing the dev environment, is hosting my app service. And I'll click on that. And I'll go browse. And hopefully it'll come up soon enough. And there's no fire and flames. But this, again, this is my dev environment, and with any luck, the variable substitution process has kicked in, and there'll be the appropriate substitution. You should see it come up soon. Come on, you can do it. All right, so here we are. And here's where it's been replaced up here, environment Kloud dev. That's all good. If I go back into this definition, and I go have a look at the QA environment, and have a look at the variables there, I've got environment description Kloud QA. So if I go back into the Azure portal, I'll close that old site down, and I'll go to my QA resource group. Obviously, I've previously deployed this, but I will touch on the deployment process a bit later on. I'll go have a look at this website and spin it up. And we should see that Kloud-QA has been replaced, and we should see it as part of the application as well. Chug, 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 chug. Come on. Okay, cool. So Kloud-QA. So very briefly, that's kind of how it works. For this PAS instance anyway. So I've got these, just to recap, I've got all these environment variables defined across all these environments. Just from a security perspective, and a very light security perspective, you'll notice that I've got these little padlocks here. So the idea is that perhaps someone will come in and define these secrets, and then they'll click on the padlock, and everybody else who comes into there won't be able to see them. So if I click on the padlock here for even more, for my secret variable, I'll hit OK. I'll save that. And I'll go back in there, configure variables, and you can see that it's grayed out there. If I unclick that, it's not supposed to do that. Let me refresh. Okay, so I had to refresh. And I unclick that now, and the value's actually gone. I'd have to put in the actual raw value. So it's not super secure, but it's enough for a very basic level of obfuscation in that someone can define these variables for you. The developers don't have to worry about it. They just have to have the substitutions defined for them, and you can carry your values across your environments that way. Okay, moving on. Okay, so with CD, we don't want to in the CI process, we did a lot of testing. We don't want to stop that as we're going through our deployment phases as well. So we might want to consider doing a degree of load testing as we're going through our environments, not necessarily on the development environment, but say you're going to QA or you're getting closer to production. You could consider running some short bursts of load testing, and I'll show you the step for that in a second. But just to ensure you haven't got any regression. So that might be a dashboard page or a few pages within your app where you have a known response time. As you're progressing through the environment, you can just throw a quick load test at it to make sure that it's within certain boundaries and it's not causing any form of regression there. And VSDS provides that pretty easily, so there's no reason not to do it. And again, I'll just jump in there very quickly. So in my dev environment, I've just got a deployment, a resource group deployment and deployment of the site. But in the QA, I've got the same, but this test here is a quick web performance test. And I'm saying, all right, I'm just going to go to this website URL, which is that QA one that you saw before that I showed you. Going to the home page, a user load of 25, going to run it for 60 seconds. And I'm going to make sure that it's going to fail the test if the response time is less than 2,000 milliseconds or 2 seconds. And that's it. I don't have to do much else to that. So it's pretty easy just to do those short burst load tests. You can do much more comprehensive tests as you're going through your environments. But again, these take, the more complex, the longer that they take to run. But they are quite valuable, so consider where in that environment step you may want to run these things. These simple ones are almost a no-brainer. They're very good to just hit your basic pages. As you're getting close to production, where you really want to make sure that things are running well, you can run some more comprehensive load tests against that.
You also, with regards to load testing, may want to kind of consider a saturation test. So maybe on a Friday afternoon or Saturday morning, just automate a day-long test to saturate your site. Because it's usually those kinds of long-running load tests that identify issues with regards to deadlocks and code locks and all those kinds of things that you may not see with a short burst test like Paul just showed you then. Looping back around to security testing, kind of earlier we mentioned Readify as a kind of a static code analysis tool for scanning for security vulnerabilities. There's an open source tool from the OWASP team called ZAP, Z-A-P, that allows you to perform a penetration test against your deployed application, perhaps in your development environment. It's easy to install, it's easy to configure, it's easy to automate, and it will identify issues that a code scan may not, such as the headers that your servers are returning and so on and so forth. Things that are available at runtime, not at design time. One thing to be aware of is if you want to run a penetration test, maybe a more advanced one against an Azure kind of deployed workload, then you should notify Microsoft that you're about to do so they won't block traffic going to those sites that they believe are under attack from your penetration test. Yeah.
Okay, moving further down the CD stack, functional or UI tests. These are typically the longest to run and most brittle. This is where users are simulated against, say, a website. They're literally clicking elements and putting entry into text boxes, those kinds of things. The tests themselves take a little bit longer to write. Again, you've usually got to spin up some extra infrastructure so that you can run these tests. There are these organisations out there, and if you're using Selenium, Selenium's a popular tool of choice to do these automated functional tests. They will spin up a grid of Selenium machines to run your tests in parallel. Because if you're running your test, it's clicking on a box, it's waiting for clicking on a button, it's waiting for some response, it moves over to the next page. If you've got a lot of those, it can take many hours to run. And a few customers of mine, these things take 6 to 8 hours to run. So it's not something you want to typically do from, environment to environment, although it can do, but quite often you might run them overnight or something like that and then report the results later on. They're extremely valuable. But again, as you're getting closer to prod, you probably want to start running them and making sure they run overnight, just so that they're still providing value, but they're not interrupting the quick process of your CI and CD pipeline, if that makes sense. Okay, so environment progression. So there's a few ways to do this. You saw in VSTS how I've got dev QA and prod. And it can work a little bit differently for infrastructure. Chris talked about infrastructure as code, and there's ways of progressing that. And you can also do asset promotion, which is kind of the default method for VSTS. It's certainly one of the easiest for PaaS-based environments. So going from dev to QA to production can either have someone saying, boom, okay, yeah, the dev environment's good, move it on to QA. Okay, I think it's good, move the next one onto production. Or you can even have that automated as well.
So if you are managing infrastructure as code and you want to promote that infrastructure, like infrastructure code through environments, then as an infrastructure programmer, much like an application developer, you can use branching techniques such as the Git flow one to manage that, not only manage that infrastructure code, but promote it through branches and prepare it for deployment release to different environments. So an example of that, your developers and your operators may be working in a develop branch on kind of the next features to be deployed. And whether it's app code or infrastructure code, that code can be built and deployed to a development environment. And then when it's ready for release, for example, to QA, following this technique, or even production, following this technique, you can create pull requests from the commits in the develop branch to pull them into the master branch to be built and deployed into your production environment. So application developers are used to this, right? This is kind of based on Git flow. Infrastructure programs can follow the same branching approach to do so. It's not limited just to master for deployments to prod or develop for deployments to development environments. You may want to consider creating release branches to prepare for an upcoming production release and maybe build that and deploy that to your QA environment for UAT testing, UA testing, for example. So really the key takeaway from here is that whether you're managing application code or infrastructure code or even your pipeline code, it's good to follow the same as a team, unify the method on which you want to manage that code through environments and using branching as a way to do that.
And we've sort of seen the environment set up in a PaaS-based system with VSTS. So talked about manual approval steps where someone says, yes, things are okay to move along, and I'll show you that now. And this is kind of the easiest, again, the kind of the default setup in VSTS. So here I've got my 3 environments, and for dev, this is something that gets automatically deployed to once the CI is done. So if I have a look at the approvers, it's automatic, there's no one there. If I go to QA, you can see I'm the specific approver there. So once dev's been deployed to, it's not going to move on to QA until I've given the OK. And the way that's visualized in VSTS, if I go back here, you can see here I've had a few failed builds, but the most latest one has gone from dev here. I've got QA next, and now it's waiting to go to production. So if I click on that, it says OK, pre-deployment approval pending, and I can say all good. Hit approve. And eventually, okay. So now that's actually kicked off a deployment to production. So that's pretty easy. And manual approvals are, again, pretty much the default at the moment. They're obviously quite easy to do. As you grow a bit more mature, though, you might want to have some further quality gates that can set certain flags to be true, and you can further automate this approval process. So instead of having a manual approval, you may want to have, say, when it's going into your QA environment, you run these code quality gates that we saw before, the security scans, these kinds of things. That can set a move to QA kind of environment variable, and that can actually kick it off. But you probably don't want to do that at the start. You want to develop some confidence in the pipeline first, which is why manual approval is kind of the default scenario there.
VSTS also supports manual interventions, as does Octopus and other deployment services. So the difference between an approval and an intervention is the approval kind of allows the deployment to run, Manual intervention may be one step in that deployment pipeline where you're deploying to a staging, to your blue environment. There's a manual intervention that requires someone to go and verify that that deployment has been successful. It's working, it's functioning, it's behaving. And then as a result of completing that manual intervention, you may then have a following step to automate the deployment of that or the swapping of that blue deployment into your live environment, for example. So you can introduce in manual interventions or steps along the way as well.
I told you it didn't get any better. Okay, we're getting towards the end game now. So we've gone through our deployment pipeline. We've deployed to production, all those tests pass, and everything is super awesome. But we want to make sure that everything's going really well. So it's important to adopt some performance metrics while your application is in production. And I mentioned up there, App Insights is a really good Microsoft offering that kind of comes, it's just so easy to sort of enable in VSTS. It's extremely valuable. I'll show you that in a second. But there are quite many other performance measurement tools out there, New Relic being another one. The important fact, though, is that make sure you are measuring something. So when it gets into production, you want to make sure that it's performing well, that it's not sucking the CPU dry, memory's good, response times are good, and set up alerts to do that. So you make sure your response time, as I showed you with the performance test, that it's less than 2 seconds or whatever you deem as an acceptable response time, ideally less than 1 second. In addition, usage analytics, is Google Analytics, Kissmetrics, there's a million others out there. Also want to gather some more metrics around just general usage. And Azure can provide this as well to a degree. GA and Kissmetrics are probably a bit more advanced in that space. But again, regardless, start to gather those and aggregate those together with your performance metrics. Finally, with user feedback, ideally, there's many other providers that will allow you to add this easily to your sites and things. Allow users to provide feedback about pages. If you're getting your performance metrics back saying that response time is sub-second and I've got no CPU issues and everything's awesome, but the feedback coming back from users saying, well, your site sucks, it's too slow, obviously there's some discrepancy there. So perhaps your metrics aren't really measuring what you think that they're measuring, so you need to revisit that. So it's just part of correlating what's real and what's you're measuring, so don't just assume that you've clicked a few buttons and everything's good to go. I'll just show you App Insights very briefly. Okay, going back into the portal. I'll close this guy down. Let's go to the dev one. So my resource group for the development environment. Okay, I've got my app service, which is the site, app service plan, which kind of dictates the resources and the setup that it's associated with. And here's my application insights. So if I click on that, and App Insights gives you some good metrics. You can see I've got one alert, and typically that'll probably be the response time. I'll show you that in a second. Server response time here, 1.2 seconds. I've got some nice graphs showing me some general stuff. I'll jump into the alert quickly. And I've got high server response time, so server response time is greater than 1 second. So I set that up. So typically when it first spins up, it takes a bit of time to get going, which you saw. So that was probably why the high response time was triggered. Additionally, I can go into search. And you can see I've got a whole bunch of requests being made here. Within those requests, I can say, because it goes off to a weather service, so I know it gets used a lot, and it's easy enough to search through that. So this isn't really a deep dive into App Insights, but the important point is that it's easy enough to associate. I'm getting some nice graphs around CPU usage. I can set alerts on memory usage, response time, which I've set up, and it's easy to go through trace logs. You don't have to set that up for you. Azure's got all that built in. There's many other tools out there that do that as well. But if you're using Azure, then it's just really easy to enable.
Yeah, just maybe to state the obvious on this, but so many times I've seen this forgotten, is that you may automate to the hilt your build and test and deployment activities. But if you're blind when you go to production, because you don't have any monitoring or measurement or alerting, that's fail as far as I'm concerned. If anything, this is more important in automating everything that leads up to this, in my mind. So without the right amount of monitoring, you don't have to monitor everything, or the right amount of alerting, and you don't have to alert everything. If you're blind to what's happening in production, you're really not operating your application, managing it well. Alerts are easy to configure, they're easy to create, and they're easy to send to email or a Slack channel. But again, if they're not actually being actively monitored by someone, that's a fail. So once you've set all this up, you've still got to iterate over this, you've still got to optimise it, you've still got to tune it over time as you learn more about your application behaviour and how it's being used. So invest some time in this as much as you do in your CI and CD pipeline.
Okay, final demo. To do this, this is where we're going to build out a CI/CD pipeline from scratch, including team services account, app insights, the whole shamil in about 10 minutes. So the way I'm going to do that is using something called a Yeoman generator. Who here is familiar with Yeoman? A few people. So it's a scaffolding tool that's typically used to scaffold out websites, JavaScript frameworks, the billion or two of those. But we're going to use it to scaffold up a CI/CD pipeline. And I can't take the credit for the generator itself. It was done by a guy called Donovan Brown, who's a Microsoft Senior DevOps Program Manager, I think. There's a URL to it there. It's open source. And towards the end of this, you'll see how effective it is. But the important point is that, yes, you can use it and you can create your CI/CD pipeline and modify it, or you can go to the open source itself and just create your own for your own organisation. So I'll have a look at this.
I hope it takes 10 minutes because we've only got 10 minutes.
Yeah, I know. Okay, so what I'm going to do is say yo team. Can everybody see, is that text big enough? Guys up the back? Yeah? Okay, I'm seeing nods. All right, so I'm using Yeoman to call the team Yeoman generator. Well, that spins up. Actually, before I do that, just quickly, I'll show you what I've got here. So this is my resource groups that I've currently got at the moment. If I hit refresh, all good. If I go here, and I'll go to my home with my team services. Go to the overview. Okay, I've got DevOps Deep Dive Demo and my personal projects. Fantastic. So I've called up this team generator. I'm going to use Kloud, my personal account. I'm going to my access token, which I've specifically generated in VSTS, so you can feel free to copy it, because after this session I'm going to destroy it. Okay, it's going off to VSTS now. It's going to find what queues I've got. I'm going to use the default hosted queue. I'm going to build a .NET Core app. So the name of my application, I don't know, we'll say Chris smells funny. We'll do a Azure App Service. I could do Docker. Docker's currently foobar on my machine, so that's not going to work. So I'll do an Azure App Service. So it's off getting my subscriptions now. I've only got one, which is this free trial. Thank you, Microsoft. Do I want to install dependencies? No, that'll just pull down all the JS dependencies. So what it's going to go and do for us is it's going to go off and create a team services account for us. It'll create a CI pipeline, which you saw before. It was very similar to that deep dive demo pipeline. It'll also create a CD pipeline, but before all that, it'll also make sure that we've got a Git repository set up in our team account, an empty one, and it'll clone that down to my machine. It'll then go off and find the default .NET Core template code, and it'll pull that down into my machine, but it won't update the repository yet. It'll expect me to do a Git push so that I can kick off a CI and CD pipeline. And so that's going to spin around for a bit. It's creating a CI build definition now. And the important thing to remember here, though, is that once we get to the end of this, it becomes remarkably easy to build out the CI and CD pipeline. And it's something that you can start up, tear down, much like the immutable infrastructure concept. So I'm going to go call into that directory, and I'm just going to do a git push. Because again, it pulled down the source code for me, but it didn't push it up to my repository. In order for me to kick off a build in a CI/CD pipeline, I need to do a push or a code change. So it's pushed the code up. And let's go have a look at our team services account to see how it's going. So if I refresh this, okay, so we've got in there Chris smells funny. Now I can go have a look at the builds. And there's my CI there. You can see that it's actually currently in progress. And let's go and edit that. Boom. So you probably can see this is very similar to my deep dive DevOps demo. But it's gone and created all that for us. So it's running Bower, the restore, running the tests, cool stuff like that. Haven't had to really do anything. Now if I go over to the release, come on, you can do it. It's gone and created all these 3 environments for us as well. In addition to the deployment steps, deploying to Azure for us, setting up resource groups, these kinds of things. So as part of its setup, it's gone and it's got some Azure resource ARM templates in there that will create a resource group for us, create an app service plan, app insights, and all the pipeline for us. So we really don't have to do anything. And we'll make sure that that is in fact working. So going into the build. Still going in progress. So go have a look at what it's doing. Go that guy there. Okay, so we've run tests. It's actually done the code coverage. It's publishing the test results as well as the code coverage results. Now it's starting to publish all the artifacts and ready to kick off a development build for us. So while that's going, well, that's almost finished, I'm going to go over to my dashboard. So that's actually finished now. So now we should see actually, before I go to the dashboard, that this guy's queued up to go. So if I go to that, release, actually open this guy. Yep, so dev's in progress. So now that's deploying to a dev environment. While that's going, I'm going to go to the dashboard because that's, 10 minutes taking too long. I'm going to delete some of these guys.
Who cares about work?
Yeah, don't worry about that rubbish. So I might go and add in a, where are we? Code coverage. Let's add that guy in. Deployment status. And pending release approvals. Close that down. We'll go over the code coverage. So, right. What do I want? I want the Chris Smells Funny CI. Okay, 20% code coverage. Haven't really coded anything. Not bad. I'll configure this. Select the build definition, CI. I'll go to release. Dev, QA, and prod is what I want to monitor. Save that. And so you can see that dev's currently being deployed to, and we have no pending release approvals currently because it's still going to development. So going to my Azure portal, I'll hit refresh there, and you can see I've got my resource group created there. And having a look inside of that resource group, we've got the app service plan, we've got the app service, so clearly it hasn't finished provisioning the app insights instance for us, although it will get there. Going back over to release. So just out of that, I mean, I've got a reasonably informative dashboard in only a few minutes, which is pretty cool. And I'll go open that up. Oh, cool, it succeeded. So back over here, if I do a refresh, there's my App Insights instance. If I click on the app service, and browse to that. Now while that's browsing, I'll go over here and I'll say, look, preemptively, I think that that's probably okay.
You don't really do this, have you?
No, you shouldn't really do this, but in the interest of the demo, yep, all good. let's approve that to go to QA. Going back to the website. Okay, so we've got a working website in our development resource group, and we've also approved our next build. Let's just refresh that. Okay. Oh, go to logs. We can watch that run through. Currently waiting on an agent, but nonetheless, we have a fully working, fully functioning CI/CD pipeline. We've got a dashboard that is showing us code coverage and the deployment status, as well as any pending approvals. And deployment status, boom. Okay. So, again, in roughly about 10 minutes, I think it was 10 minutes, you've just been given a CI/CD pipeline. We've set up, dev, QA, prod with an approval process to get through that CD pipeline. You've got some monitoring set up in all those environments. In addition, we've just set up a quick dashboard while that's been happening to give us immediate feedback into what's happening. Obviously, you can customize this to the nth degree. But the important point is CI/CD, while it seems like there's a lot of steps involved, it's actually really, really easy, at least to get started. Especially if you're on a new project, you can just run this generator and just customize it to suit. If you want to get more creative, go and get the source code, create your own generator that suits your organisational needs. Okay. I think we're pretty much done, are we? We got one more? Yep. So I guess just to summarise, when you're starting a new project, begin building all this as you go, and that Yeoman generator is a perfect place to start. Yes, it's .NET Core, but it's easy enough to change the steps. Understand your environments. Chris talked about that initially, and it is extremely important to do so because that'll dictate how you're going to construct your CI/CD pipeline, and just continue to go over it. So go back, see things that are working or not working, and change those to suit what you need. Is there anything you want to add to that, Chris?
Yeah, just again, revisiting an earlier point, you don't have to invest a heap of effort up front, like some people kind of either automate or die. I don't believe in that. Automation or lack of automation won't kill you, but more automation will help you. So as Paul's already mentioned, get yourself started, iterate over it, make sure it's in your product backlog alongside all your application features, continue investing in it and maintain it and support it over time, and you'll get some obvious improvements out in the back end of it. So yeah, that's all for today.
Yeah, thank you very much everyone for coming along. Is there any questions? I know we sort of went a bit over time. Yes? For the approval process?
Yes. For the secrets.
Like the secret password, instead of being stored, to be prompt to the user?
There's no way that I know of to do password prompt. It's based off the, who you assign to do it and their privileges within the team services account. So you're leveraging all the security as part of Active Directory and VSTS, but no, just password entry. Yeah. Any other questions? Yes.
How do you promote database security to speed the
Haha, the old database migration.
Question was, how do you promote database updates? If you can use Entity Framework or DBUp or a similar tool, you really want to manage your schemas like you do your code. I would always suggest that you, if you're not writing the migration script yourself, you're having it generated for you, and you review that and manage that with your application code. So as a deployment step, you would automate the deployment of that database update. Obviously, you want to make sure that those migration scripts are backwards compatible with your current version in production. Otherwise, you're going to break that current version before you swap your new version in. So certainly investigate tools like DBUp, or if you're using any framework, code first migrations, as a way to manage those database updates and rollbacks if you pull a new version out of production. Does that make sense?
My personal preference is to use just a scripting method like DBUp, essentially just SQL scripts. There's Redgate tool, SQL Source Control, which manages a lot of that for you. But it is important as you're migrating to environments that if you're doing database migration scripts, don't drop tables and create massive indexes and all that kind of thing. That's going to hold your site up. So doing those migration scripts, you sometimes have to get a bit creative because you don't really want downtime, especially if you want to hit production all the time. So make sure that those scripts don't cause any locks, database locks or anything. Those kinds of changes you may want to defer to, like might be a downtime process or non-peak times or something like that. That really depends on the change itself, so be careful about what kinds of migration scripts you do write.
Also consider scripting your data, your scripting data into your databases. So you may have master data or reference data. I script all of that as well. So there may be a new table to be added to be filled with an initial set of reference data. I script all that, so it just is kind of transactionally consistent, and you can always script it out as well. Yep.
You were first, yep.
So is it important to unify the source control? So for example, Puppet is using Git for the source control and other applications using TFS. So is it recommended to use a unified source control?
So the question was, is it recommended to use a unified source control if Puppet's using Git and we're using Team Foundation version control? Look, ultimately I think it would be better to be unified. However, it really comes down to how your teams are going to work. If you're working on discrete areas, I guess there's no real reason why you can't use different source control mechanisms. But if you've got to have one team that's got to cut across 2, 3, 4 different source control systems, that's probably going to be an impediment you want to look at removing.
So we talked about configuration drift earlier. If you have code drift, whether it's app code or infrastructure code or any other code, if you're introducing drift and inconsistency, you're going to be up for a bit of pain. So I would suggest that evaluating different tools that you want to use in your DevOps tool chain, to consider that as a key requirement. I always would, where you can unify all that code in the same repository and treat it as one.
Yeah. And did you have a question as well? So the question is tips on optimizing the merging of code.
Merge early.
Yeah, merge often, merge early, and God, just write good code. That's there is no general guidelines there. I mean, I've seen teams that are quite disciplined teams still going through merge hell. So it's not a unique proposition or a unique problem for people to have. It is a hard problem to solve, and depending on the tool set involved, I don't know if anybody remembers the old EDMX days of Entity Framework and trying to merge that if you're ever doing any changes. I had hair back then, but now it's all gone. So to answer your question, there's no easy way to dictate that.
Yeah.
So see Omar, he's the merge consultant up the front here.
Feature branches are good to use, I feel, but you still want to be making sure you're kind of merging down from develop, if you like, as often as possible. So hopefully it makes the merge up a little easier.
Yeah, so the longer that they run, you want to keep on merging to making sure that you're resolving conflicts early.
Yeah.
Any other questions? Okay, so that about does it. Again, thank you for coming so early in the morning. I really appreciate it. Thanks again.
Evals.
Oh yes, evals.
Get a chance to fly a drone. Have a good day.
Thank you.